students. Now we are going to discuss the topic that is why questions on amines, that is nitrogen family. Let us start from last question. Amine, that is amines acts as nucleophiles. Here RNS2 is amines or it is primary amine. Amines acts as a nucleophile. Why? Because you know amines having lone pair on nitrogens. As it is having lone pair electron density on the nitrogen atom, so it is attracted towards electrophiles. As it has electron density, source of electron on nitrogen, that's why it attracted towards electrophile. That's why it acts as a nucleophile due to availability of lone pair on nitrogen. Okay, this is the answer. Then question number 19, bromination of aniline even in mild condition gives 2,4,6 trinitro-bromo aniline. Why it gives 2,4,6 tribromo aniline even on mild condition? Because the aniline, what happens, this amino group having lone pair, due to lone pair nitrogen, it activates the ring. And if you see, it activates the ring and the electron density at ortho position, para position increasing more. That if you see, and same you see ortho position, this is your ortho position, this is your para position, this is your ortho position. So 2, 4, 6, this position getting more negative charge due to resonance, delocalization of lone pair of nitrogen towards the benzene ring. That's why the reactivity of aniline increases. On mild condition also bromination takes place, forming 2,4,6 tribromo aniline due to delocalization of lone pair and forming more negative charge at ortho para position. That's why it forms 2,4,6 tribromo aniline. This is the answer. You have to draw the structure, resonance structure. When you are explaining any Y question, reasoning question, you have to draw the structure when it is required. When it is necessary, you draw the structure. It will be better for the examiner to understand your explanation. Then question number 18, diazonium salt BDC not stored and used immediately after the preparation. That means it should not be stored because it decomposes at higher temperature. At room temperature it decomposes. Although it is stable compared to aliphatic, but it decomposes at higher temperature more than room temperature. Ordinary temperature, room temperature also decompose. That's why it should not be stored because it decomposes at higher temperature. This is the answer. It decomposes. Then silver chloride dissolves in amine. Why it dissolves? Because it produces a complex. If you write the reaction, RNS2 and AgCl forming one complex. Complex is AgRNS2 whole 2 whole bracket plus. This complex is produced by the combination of amine and AgCl. That's why AgCl is soluble in liquid ammonia. AgCl is soluble in amines solution. So due to the formation of complex, amine complex. Then 16. Aniline is weaker base than cyclohexylamine because this structure you see, as aromatic amine has resonance, due to resonance electron density on nitrogen decreases. That's why basic character decreases. This is the answer. As it has resonance due to delocalization of electron from nitrogen due to the resonance structure, due to resonance. That's why the electron density on nitrogen decreases, so basic character decreases. Tertiary amine does not give acylation reaction because tertiary amine has no substituted hydrogen attached to nitrogen. As it has no hydrogen attached to nitrogen, so substitution is not takes place. That's why tertiary amine does not show acylation reaction because it has no substituted hydrogen. We can say like this, it has no substituted hydrogen. That's why it does not show acylation reaction. Phenyl cyanide, that is, you can say benzonitrile, we can say benzonitrile. Benzonitrile cannot be prepared by the action of, that is, haloarine with sodium cyanide. Haloarine with sodium cyanide, why the reaction is not taking place? Because already know, just one, let me erase this one. Here what happens? Here as chlorobenzene, if you see, chlorobenzene, if you draw the structure, chlorobenzene does not react with sodium cyanide. Nucleophile substitution is not possible because due to resonance double bond character of chlorine. Due to resonance, chlorine becomes double bond with the benzene. It produces double bond with benzene. That's why Cn minus cannot be substituted Cl. Due to double bonds, more stronger bond is produced by resonance. That's why it does not react. Aniline is more reactive than benzene because already we have to know aniline has, what happens? Aniline has resonance, that which resonance plus N or plus R. Due to plus N or plus R, electron density on the ring, in the ring increases. As the electron density in the ring increases, that's why it is more reactive than benzene. This is the answer. Okay. Then aniline gives orthopara substituted product. Already we have discussed. You see, this is the mechanism. Here ortho position, here para position. That's why electrophile attack produce ortho and para product. Here we attach plus para. Both sides, ortho position and para position gets substituted due to resonance. Ortho position, para position getting more negative charge. That's why it produces ortho para substituted product. Then Hinsberg reagent does not react with tertiary amine. Same, tertiary amine has no replaceable hydrogen. That's why as it has no replaceable hydrogen, it has no reaction with tertiary amine because it has no replaceable hydrogen. To substitute this Hinsberg reagent in tertiary amine, it should have some hydrogen attached to nitrogen. As it has no hydrogen attached to nitrogen, so there is no substitution takes place. That's why Hinsberg reagent does not react with tertiary amine. But that BDC, benzene diazenyl chloride, is more stable than your aliphatic, that is aliphatic diazenyl salt, because if you see more stable because due to resonance. If you draw the structure, here you can draw in this way. If you draw the structure of this, if you draw the resonance structure of benzene, it will be like this. Okay, so due to resonance, due to delocalization, due to resonance, it has, what happens? Due to resonance, due to delocalization of pi electron, this benzene N bond become more stronger. That's why it is more stable than aliphatic. But you can say another, if you dissociate this position, it will produce phenyl cation. It will produce phenyl cation. As phenyl cation is unstable, so it does not dissociate through this bond. But in your aliphatic diazenyl salt dissociates, produce R plus. R plus is stable, but C plus is unstable. So in different way you can write. This is also one type of answer. When it dissociates, produce phenyl cation. Phenyl carbocation is unstable. That's why it does not dissociate. But in aliphatic condition, it produces R plus, alkyl carbocation, which is stable. So this is the difference between aliphatic and aromatic. Or you can say aromatic compound stable due to delocalization of the nitrogen from delocalization with the benzene ring by resonance. That is also answer. You can write this one. Before nitration, aniline should be acylated because before nitration, aniline should be acylated because you see if direct nitration will be done, if direct nitration will be done with the nitric acid, then aniline group will be oxidized by nitric acid, produce anilinium ion. Produce anilinium ion. This anilinium ion undergo nitration forming ortho-meta-para, both ortho-nitro, para-nitro and meta, both produce. As we produce ortho-meta-para substituted mixture of nitro substituted aniline is produced during the nitration, because amino group easily oxidized by nitric acid forming aniline. This is the answer. Because if direct nitration will be done, then alanine will be oxidized by nitric acid from forming anilinium ion, and it produce ortho-para-meta substituted benzene, aniline. That's why it should be acylated. It should be acylated. During acylation, the amino group is protected by acyl group. This acyl group or CO group will protect the amino group, so it will not be easily oxidized by nitric acid. Then you can do the nitration. So before nitration, aniline should be acylated, because if direct nitration will be done, then nitric acid oxidized aniline forming anilinium ion, which gets substituted forming ortho-para-meta substituted product. That's why before nitration it should be acylated. Okay, so wait. Amine is less acidic than ROH. Why amines are less acidic? Because it is small size. As nitrogen is small size, the NH bond is stronger than OH bond. As NH bond, as nitrogen due to this NH bond is shorter than the OH bond. That's why, or we can say less polar. It is less polar than alcohol. As less polar, you can write this answer is better. As it has less polar, amino group, this NH2 group is less polar than OH. That's why amine are less acidic than alcohol. Due to less polarity, due to less electronegativity, less polar, less electronegativity of nitrogen. Different answer you can write. Then secondary amine is more basic than tertiary amine, because secondary amine, if you draw the structure, secondary amine is more basic than tertiary amine in case of aqueous medium, because tertiary amine has low that hydrogen bonding, that is your hydration effect is low, then steric factor is more steric factor. Tertiary amine has more steric factor and low hydration effect, solvation effect, we can say solvation effect, low solvation effect and low hydration, that is hydrogen bonding, low hydrogen bonding and low solvation effect, and high, that we can say high steric factor due to 2-3 methyl group, bulky group. That's why it is less basic. This is the answer. Why tertiary amine is less basic than secondary amine, although it has 3 methyl group? Because due to steric hindrance, due to steric effect and low solvation effect, low hydrogen bonding with the water molecule. That's why tertiary amine is less basic. Then primary amine has higher boiling point than tertiary amine, because primary amine can form better hydrogen bonding. The hydrogen bonding HB, hydrogen bonding of primary amine is more than the tertiary amine. Tertiary amine has no capability to form hydrogen because it has no polar hydrogen. As it has no polar hydrogen atom, that's why the hydrogen bonding is very weak. It cannot form hydrogen bond with water. That's why the solubility is very low. Although the size is more, hydrogen bonding in case of primary amine is stronger. has stronger hydrogen bonding, so volume bond is more. Amines, primary, secondary amines are water soluble because it forms hydrogen bond with water. Intermolecular hydrogen bond with water, that's a water soluble. Aniline does not give Friedel cup acylation, alkylation because aniline reacts with ferric chloride or aluminum chloride of alkylation. Aluminum chloride, we know alkylation, acylation, generally aluminum chloride is used as a Lewis acid, so it forms salt. It forms salt with the NH2 plus AlCl3 minus. As produce salt with the aniline, that's why acylation or alkylation is not possible by aniline. Very important this one. Methylamine is water in water reacts to the ferric chloride, gives reddish brown precipitate because if you see methylamine in water, what happens? You have to write this reaction. Produce NH3 plus Rn. Already I have told you what water is more acidic than amine. That's how water loses H plus to amine. So RNH3 plus OH minus. As OH minus is available, ferric chloride that produces ferric ion and OH minus ion forming ferric hydroxide. This ferric hydroxide has a reddish brown color. That's why amine in water, in presence of water, reacts with ferric chloride forming reddish brown precipitate because it produces ferric hydroxide. It produces ferric hydroxide compound, that's a reddish brown color. Then aniline is less basic and more pKb than methylamine because aniline, we already have discussed aniline. What happens? Aniline has resonance. That's why the electron density of nitrogen decreases. That's why less basic, higher pKb. Less basic means higher pKb. And your methylamine, as it has which effect? Plus I effect. Methyl group has plus I effect. So it increases electron density of nitrogen. That's a more basic. But aniline due to resonance, electron density decreases. You have to draw the structure. You have to draw this plus I effect you have to show and resonance also you have to show. Then you can explain clearly that why aniline is less basic than amine. That's why less basic means more pKb. Then aromatic amine cannot be prepared by Gabriel phthalamide synthesis because we know the preparation of amine from Gabriel phthalamide synthesis we have to use some haloalkane. But we know haloarine as preparation aromatic amine, haloarine should be used. Haloarine generally does not show nucleophilic substitution reaction. Haloarine does not show nucleophilic substitution due to resonance forming double bond. That's a stronger CCl bond is produced by resonance. That's why it does not show nucleophilic substitution reaction. That's why Gabriel phthalamide synthesis one nucleophilic substitution reaction takes place between haloalkane and your phthalamide as substituted phthalamide. As to prepare aromatic amine we have to use chlorobenzene or any haloarine we have to use. Haloarine does not show nucleophilic substitution reaction. That's why it does not show Gabriel phthalamide synthesis. Or aromatic amine cannot be prepared by Gabriel phthalamide synthesis because you have to write like this. Why it cannot be prepared? Because chloro or haloarine does not show nucleophilic substitution reaction. That's why we cannot prepare aromatic amine. Aniline we cannot prepare. This is the answer. Okay. So when you are writing the reasoning question, why question? First read the question carefully. Once or twice you read the question, then you write the exact answer to the point you write. For example, aromatic amine cannot be prepared by Gabriel phthalamide synthesis because haloarine does not show nucleophilic. If it gives nucleophilic substitution, then this group can be substituted, then produce your aromatic amine. As it does not give nucleophilic substitution, so amide cannot be substituted in this place. So you cannot prepare aromatic amine. So this is the answer. But students, what mistake they are doing? They will write aromatic amine does not give nucleophilic substitution reaction. That is wrong. Chlorobenzene does not give nucleophilic substitution reaction. That's why aromatic amine cannot be prepared. Answer should be correct, accurate as per the question. what is asked, your answer should be accordingly. Then you will get the marks. Okay? You prepare, any doubt, you can ask me later. Okay? Thank you.